In lecture IN1a, we introduced what we mean by Euclidean space and said that Euclidean geometry that is guided by the building blocks, namely point, angle, distance, holds in such a space. Euclid applied his geometry to 1D, 2D and 3D. Today we will discuss the dimensionality of space, of the region we reside, in other words, of the universe. So the topic goes as follows. Is our space three-dimensional? Do we live in a three-dimensional world? Let me start with a quote of Einstein, who said, "Imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. Logic will get you from A to Z. Imagination will get you everywhere." Some brilliant authors who, in their flight of imagination, took us to places or regions which enriched us in many ways. Let me start this lecture with a science fiction written by H.G.Wells, a prolific English writer, namely the Platner Story that was first published in 1896. Plattner was a school teacher in the south of England and in chemistry class tried to experiment with a green powder from a bottle that a boy gave to him. And you know that experiments in chemistry lab should be done with utmost care. And there are some potentially explosive mixtures one has to handle sometimes. Plattner was indeed careful but could not avert an explosion. The explosion made him disappear from this world or universe, and Plattner found himself, of course still with the bottle with the remaining portion of green powder, but now in a parallel world. Indeed, the explosion made him move into a fourth dimension. He could not realize any change in himself in this new homeland, could see everybody and everything from this fourth dimension, the schoolroom, the people, but strangely, none was aware of him. None recognized him, rather, all walked through him. A strange and unusual situation. It was as if the two worlds overlapped. After 9 days, Plattner all on a sudden noticed a man on the verge of his death, and his wife, who was much younger to him, was in frantic search of something. Yes, the will made by the man in the deathbed, the legal document in which perhaps the man declared how his assets would be distributed and to whom. As luck would have it, she found the will and immediately set it in flames of a candle. Plattner then had an eerie experience, a strange and frightening observation. He suddenly saw a shadow of an arm that was extending from nowhere, and the man who was doomed to die was engulfed in the shadow. The shadow, so to say, was about to swallow the dying man. The horrified, agitated Plattner panicked, could not control himself, and had a great fall. the green powder exploded, and he found himself again back on the planet Earth, where he was doing an experiment just 9 days ago. Now, Plattner was flabbergasted. He was astonished, dismayed, as he found himself turned into a left-hander. All his anatomical features got inverted left to right and right to left. Everyone was dumbstruck as they compared an old photograph with him. He understood that his passage into fourth dimension took a toll and flipped him altogether, in the true sense of the term, and he was crazy. The narrator of the story succeeded in arranging for an interview with Plattner as well as the widow, the lady who did not waste much time after the death of her husband, overcame her grief as fast as she could and hurriedly remarried. Both the lady and Plattner curiously portrayed an identical picture of the room where the death occurred, though they differed on the account of events during the man's death. Now, this is a scientific fiction that gives an inkling, a hint of the fourth dimension. Now, let us not take it seriously. It is a science fiction, and let us simply enjoy it to our heart's content. And there are so many science fictions. There are science fictions on extra dimension, parallel universe, and so on. In this lecture, we will make these things clear. Let us ask, what is the dimension of our space? The answer is 3 dimension. We live in a universe which has 3 spatial dimensions, and all phenomena occur over a time. So time is one dimensional. Hence, overall, we live in a 4-dimensional world, 3 space and 1 time. It would have been better if we could end here, because I have given the final answer already. We live in 3 space plus 1 time dimension. Whenever an event occurs, say an apple falls from a tree, a scientific mind investigates it, dissects it, with the purpose of answering various questions like why, how, when, and so on. This might give you things that we are craving for, or maybe some hitherto unknown discoveries may be made. So, be that as it may, let us investigate and address some pertinent questions and take our discussion further to get an insight into the dimension of our universe without any prejudice or preconceived opinion or conception. Let us start from a scratch. So let us start with the question of what we really mean by dimension that we are referring to. Dimension is where particle can move. A number of variables that we require to pinpoint location of a particle gives the number of dimension. An event refers to place of occurrence, which is say xyz, and time of occurrence, say t. There is a particular way of writing this which you will do in your class on special theory of relativity. Now look at this. We define point in lecture IN1a. It has 0 dimension. Now double the number of points, join them, get a line. This is 1D. Now double the number of points again and join them to get a plane, which is 2D. Now double the points again, join the points to generate a box. It is 3D. So we have got to the answer. The three spatial dimensions have been obtained. Now shall we stop here? The answer is yes and a no as well. There are logics for and against. So let us discuss the pros and cons. Now if yes, why? We have shown that space is 3D, having three directions, up and down, which is denoted by x, back and forth denoted by y, left and right denoted by z. Our universe is an expanding spherical volume of radius 14 into 10 to the power 9 parsec, or 4.4 10 to the power 26 meters. The interrelations were discussed in lecture P2C in the particle physics series. A few words next about time dimension. We know that time and tide wait for none. So the time ticks, it waits for none. Time moves forward, it knows only one direction, the forward direction, which is called the time arrow. This unique nature possessed by time reminds us of another quantity you do in thermodynamics class, namely entropy, which also does not know to get smaller. It always increases for an isolated system. If system and surroundings are taken together, the entropy refuses to decrease. This is called second law of thermodynamics. Suppose we stretch a rubber band. Look at the disciplined arrangement of the molecules under tension. It is an ordered state, having a predictable arrangement of molecules everywhere due to the symmetry involved. But note that this symmetric arrangement was forced upon it by me. Now if you release the tension, that is allow the rubber band to be as it likes to be, what we see that it assumes a kinky, indisciplined, not so symmetric distribution of molecules in the non-stretched state. And of course this is the equilibrium state, the inevitable situation, its destiny. And now the arrangement is different at different places, unpredictable and chaotic. And to go back, you require forces and efforts. You need to apply tension and forces against the nature of things. So nature promotes disorder and chaos to move on to the state of equilibrium as time flows. And entropy is a measure of chaos or disorder of a system. It is a measure of the amount of randomness in a system. In fact, it is very easy to bring disorder into an ordered system. A class erupts into chaos and randomness when the teacher ends the class. But it requires effort and ingenuity to bring discipline in the class, to make children quiet so that the class can start in a proper way. How are we so sure that we live in 3D space? This is because to locate something with respect to a reference point O, we need three numbers, one along x-axis, one along y-axis, and one along z-axis. For instance, 4 meter in the front direction, that is along x, 3 meter in the left direction, that is along y, and 1 meter up, that is along z direction. Consider this situation. This is x-axis, this is y-axis, and this is z-axis. O is the origin, and this is a sphere. A particle moves upon it, say from this point to this point. Now is this movement a 2D movement or is it a 3D movement? Now this depends upon how it moves. If movement is constrained, that is, the particle is forced or instructed to remain on the sphere during movement, then it is a 2D movement. So the particle moves from this point to this point, remaining on the sphere. And since we require two coordinates to describe any point on the surface, so it is a 2D movement. So this type of constrained movement on a sphere is a two-dimensional movement because surface is two-dimensional. On the other hand, if the particle can go as it likes, there are no constraints on it, it is free to choose any path, then such free or general movement will be a 3D movement because the particle starts from here, it moves along x-axis, then it moves along negative y, and then it climbs up along z-axis to reach its destination. So the free movement is a 3D movement. So whether any problem is two-dimensional or three-dimensional depends upon circumstance, depends upon constraints, depends upon how you represent the situation, and so on and so forth. In the words of the great philosopher Kant, that space has three dimensions can be demonstrated by trying to put four lines at a point at 90 degrees, which is not possible. In 2D, we can put at most two lines at 90 degrees. Here is x and here is y, and this is 90 degrees. And we cannot put any line that makes 90 degrees with both the axes. So the dimensionality of this plane is 2. In 3D, here is one line and here is another, and this is the z-axis, and we cannot place another line in such a way that these three angles are 90 degrees. So the dimensionality of this space is definitely 3. Now we come to the question of whether at all we can realize dimension greater than 3D. Consider the case of a 2D creature first. The 2D creature can move along x-axis, along y-axis. It feels and enjoys the 2D world. Now to it, any other dimension is absolutely meaningless in the sense that it does not possess any other dimension itself. In simple terms, a 2D creature can move back or forward, it can look left or right, but there is no up and down for it. Up and down are terms which are not included in its dictionary. So a 2D creature can realize or visualize only two directions. And similarly, we are 3D beings, creatures, and it is sensible to look along x-axis, which is say back and forth, along y-axis, which is say left and right, and along z-axis, which is say up and down. And it makes no sense to search somebody along the fourth direction because to us it does not exist. We ourselves have a height, a width, and of course a depth, and no other dimension do we possess. Further, any direction whatsoever we can think of can be dissolved as a linear combination of the three directions. So imagining greater than 3D is something that is not possible for us. Let us now come to the no school of thought that says that we live in a world or universe that can have extra dimension. Now let me tell this side of the story. Now consider this wire or thread, whatever. Now is this 1D or more than that? And you have to look it from a large distance. The eye says it is definitely 1D because you cannot see the lateral dimension of it. It has only length and no other dimension is visible to you. But this conclusion that it has one dimension will not be corroborated by, that is supported by, an ant who is moving along it, because it not only can move along the length but it can also move across it, that is transverse to it. perpendicular to its length. So to an ant, the movement is 2D. In other words, ant can move along this wire, which is 1D motion, and it can move transverse to it also. Next, let us consider the motion of an ant along a rope. Let us look at the rope first. It has a length and it is thick. Also, it consists of so many twists and turns, braids. So the structure is complex, no doubt. The ant which moves on it can therefore move in a complicated fashion. It can move forward, that is moving straight along the length. It can also move transversely, perpendicular to the length, and it can execute certain other motions also. It can make circular motions along the twists and turns, braids. It is a 3D object. We are not suggesting that the dimension involved here is more than 3D. In fact, it is a 3D movement, yet it signals something new that we shall refer to at the end of this lecture. Let us consider a few more examples. Consider this sheet of paper, and when viewed from a distance it is definitely 2D. You cannot see its thickness. Another important fact is that we can make transition from higher dimension to lower dimension, as can be understood from these examples easily. The hollow box is 3D, but if we smash it, it is grounded and we get a plane, a 2D structure. This is a hollow sphere, a 3D object, but if you cut it with a knife, the section by a plane is a circle, which is 1D curve, while a hollow cylinder, if we break open, we get a circle and a 2D curved surface. If I roll this paper, by curling it, we get a roll of paper which looks 1D from a distance. So it follows that switching dimension from higher to lower is possible. And we can now put the pertinent question: after going from 3D box to the 2D plane, we can ask, where did the third dimension, the up-down sense or direction, go? The answer is definitely it is lost. So a 2D creature who now takes birth in this 2D world, in this 2D plane, has no idea of up and down, though to it the idea of left, right, back and forth makes perfect sense. And that 2D creature will never be able to comprehend or make sense of the up and down direction. Also, these ideas which we have put forward apply to objects as well as to space. In view of these discussions, something becomes very clear to us. Some dimension may have been there in the past, may not be there now. Just because I do not understand more than 3D does not mean that higher dimension is not there. Extra dimensions may make their way. They do not wait for our invitation. Also, we will agree on the fact that a large dimension is easily discernible, easily observable, while if dimension is small, it is difficult to recognize its presence. Some questions thus appear. How many dimensions shall we take? Whatever we do, it should be mathematically consistent. If at all we allow some extra dimension, say a theory based upon some rigorous mathematics allows for extra dimension, then we have to physically interpret it. The purpose, the aim, or the objective should be spelled out clearly in the beginning. And lastly, which theory increases our hunger or thirst, whatever, for searching for extra dimension? When 3 dimensions seems to be okay, to live on with. Let us start with the name of the theory. We will only answer the questions that have cropped up and not any further. There is a theory called string theory which says that universe is built out of one-dimensional strings rather than point particles, and different particles are different modes of vibration of string. So universe is described by interaction of 1D strings, and we are not going into it. Now string theory says that universe operates in 10 dimensions, and with the idea of brain put into it, the word coming from membrane, we need the universe to function with 11 dimensions. So in a nutshell, as per string theory, the universe needs to have 10 or 11 dimensions. Now, these are some of the eminent, illustrious personalities who developed string theory, and they are going on with it. Now why not 13, 15 or 29 or any other number and it is 10 or 11? Actually this 10 or 11 number is needed to get a stable universe as per this theory. Even if universe starts with say 13 dimension, it collapses to 10 or 11 dimension. So stability of universe decides its dimension, and this is quite a believable and convincing logic. The string theory rests upon certain equations which become meaningful only if number of dimension is 10 or 11, out of which 3 are spatial, and we are quite satisfied and fine with it. One is temporal, and the rest 6 or 7 are called extra dimension. Mind it, these statements are the theoretical prediction of string theory. Some captivating geometry with fascinating scenarios are attached to these extra 6 or 7 dimensions. The main characteristic or hallmark of these 6 or 7 extra dimension, as per this theory, is that they close upon them, they curl upon themselves, they get wrapped up through a process called compactification, which makes dimensions to hide into very compact space. So let me repeat again that the 6 or 7 dimensions are theoretical predictions of string theory, which is still awaiting approval of experiments that are delicate and difficult to perform. What is the need of such a theory that is so complicated and requires you to rack your brains and necessitate all out of the box thinking? Actually, you have to realize that the theory that has been developed by the best brains was not a pastime project, but was done with an intention of unraveling the mysteries regarding evolution of universe. According to the theory, the universe had at the earliest point of time one super force and existed in perfection due to amalgamation of 10 or 11 dimensions. Then that perfect universe was pulverized, was shattered because of a phenomena called Big Bang. After that, the super force split apart, and you see now we have 4 forces: the strong force, the electromagnetic force, the weak force, and the gravitational force, and they do not see eye to eye. They are different in all respects. Also, the harmonious existence of all the 10 or 11 dimensions that made the universe perfect was devastated and the universe cracked, and 6 or 7 dimensions got curled up, they got freezed, leaving 3 dimension to rule the visible world or universe. So we live in a shattered, cracked up universe. As the string theory aims to study the evolution of the universe, it tries to reach the era where all forces were bundled up to one super force. In other words, the string theory aims to combine laws of the small given by quantum mechanics with the laws of the large given by general theory of relativity into a believable, well-knit, rigorous and compact mathematical framework. So it is a sort of quantum gravity theory, Q for quantum mechanics and G for general theory of relativity. Clear from the description that to unify forces we need to go to the initial state of perfection that was possible because of the stitching of 10 or 11 dimensions. In 3D, you cannot achieve perfection. Again, we said that the higher dimensions are smaller. Now, what is the reason that they are smaller? Of course, the logic that since they are not discernible, not observable, so they must be small. But we wish to have a better logic, better reason. Now look at the structure, say a house, and if its pillars are pulled down, the house is flattened, and it is a higher dimension to lower dimension transition. The reverse transition is also possible. If we start with a wafer or a suitable platform and allow atoms to precipitate in an epitaxial growth or say any other crystal growing method, then we get a crystal. Now this is a transfer from lower dimension to higher dimension. Now it can be expected that under favorable situation, transformation of higher dimension to lower dimension or the other way around, that is lower dimension to higher dimension, can occur. If really there are higher extra dimensions, then one should observe such transformations. At least atoms should have escaped to higher dimensions. But we do not see such transition of materials or atoms. They do not disappear. So this means that they do not find enough dimensional space to disappear. The higher dimension must therefore be of smaller size than atoms so that atoms cannot disappear. After all, you need a space at least of your size to hide into. A child cannot hide in a rat's hole. So higher dimensions are expected to be smaller than atomic sizes. And it reminds us of the curly region, the braids that are associated with the one-dimensional rope, which resembles what we called wrapped up, curled up hidden spaces. I will end by mentioning two very challenging problems. One is, why is gravity force so weak? And the other relates to dark matter. I have compared the gravity force to the other forces in lecture entitled P4A in the particle physics series, and it is this thing. Now, Why is gravity force so feeble? Why is it not even in a position to challenge other forces of nature in terms of strength? The answer can be given as follows from string theory, according to which gravity force is able to permeate or propagate or connect all dimensions. It is omnipresent. It can go anywhere. So after Big Bang, as the superforce separated, the three forces, the strong force, the electromagnetic force and the weak force, got trapped in 3D, the visible world, as they did not have the gate pass to move into extra dimension. It is gravity force that can move everywhere. So in the process, gravity force got diluted as it has to take care of all the dimensions, the extra dimensions, in addition to the three-dimensional visible world. Lastly, this opens up an interesting, rather spooky possibility. As extra dimension is not what we can observe, we can argue that a universe exists hidden in the extra dimension called a parallel universe involving dark matter that hovers over our universe, which is 3D plus 1D. We cannot see the parallel universe since light cannot connect with it, but gravity can communicate, and hence an experimental detection through the measurement of gravitational effects of the parallel universe on our universe can be done. At least theoretically it is allowed. I will put an end to this lecture by reminding you that at the end of the day you should take it as a story waiting for approval. The answer to the question that we started with, namely, is our space 3D, will be yes, it is three-dimensional, spatial, and time is there which moves forward only. Let me end with this quote. God, being the first observer and saying, "Let there be light," was probably misquoted. God more likely said, "Let there be energy," and with those words our universe appeared. Stephen Leon Lipscomb in Art Meets Mathematics in the Fourth Dimension. The beauty of physics or science in general is that to accept something you need logic. To reject something we need logic. So logic, mathematics, experiments are the basic features in science. Thank you.